Today's lesson is on error intervals. Your learning objective is I will be able to find bounds and write error intervals. So our key points for today are: when numbers or measurements are given to a certain degree of accuracy, there is a lower bound that would round up to the number and an upper bound which would round down to the number. An error interval is written as an inequality and shows the values the number could be. Write down your key points and then we will do an example. Okay, example 1. Okay, a length of a piece of paper L is measured to 12 centimetres to the nearest centimetre. So the first thing we want to do is find our bounds. So we draw a number line and we pop our value in the middle. Now because it's been rounded to the nearest centimetre, we go up 1 centimetre, so we'd get 13, and we go down 1 centimetre, which means we'll get 11. So our lower bound lies halfway between these numbers, which would be 11.5, and our upper bound lays halfway between these numbers, which would be 12.5. Now our bounds tell us the boundaries of the number. It doesn't actually tell us the values that it could be. Okay, so that's why we use our error interval. So the 11.5 is included because it would round up to 12. So when we do our interval, we use our inequality signs. So this means that the 11.5 would be included, and everything up to but not including the 12.5 is included, because 12.5 would round up to the 13. So with our inequality sign, it's not included, so it looks like that. So that is our error interval. Okay, so let's have a little look at our steps. So we drew a number line, we write the number in the middle, we go up 1 unit, we go down 1 unit, and we find the halfway values. These are our bounds. Okay, the lower bound is included, so we use that symbol. The upper bound is not, so we use this symbol, and then we write in our bounds to make the inequality. Okay, press pause, write down your steps, and then we'll do another example. Okay, here's another example. So we start by drawing the number line. We write the number in the middle. This time it's 50.2. And we're to the nearest millimetre this time. So the 0.2 is the millimetre. So we go up 1 unit, so I get 50.3. I go down 1 unit, which gives me 50.1. And then I find my halfway values. So halfway between 50.1 and 50.2 is 50.15. Halfway between these two is 50.25. This is my lower bound, this is my upper bound. And if I'm asked for the error interval, we're using L for the length of piece of paper. The lower bound is included, so I get 50.15, and the upper bound isn't included, so I get 50.25. Okay, so your steps are still on the right there. So what I want you to do now is press pause and have a go at your turn. Okay, let's go through this then. So start by drawing in your number line. Write your value in the middle, so you get 60. This time it's done to the nearest 10, so we go up 10 and we go down 10. Find your halfway values. So halfway there is 55, halfway here is 65. This is my lower bound, this is my upper bound. So to write my inequality, the lower bound is included and the upper bound is not. So there is your error interval. Okay, so I've got some questions for you to practice now. Okay, if you press pause, have a go at them, and then we'll go through them. Okay then, so the first one here, draw your number line. 16.4 goes in the middle. It was the nearest millimetre, so up 1 millimetre, 16.5, down 1 millimetre, 16.3. Find your halfway values, 16.35, 16.45. That's your lower bound, that's your upper bound. So your error interval, the lower bound is included and the upper bound is not. Okay, next question. Okay, so to the nearest 2 millimetres, so these are your millimetres here. So 2 millimetres more is 18.8, 2 millimetres less is 18.4. So your halfway values are 18.5 and 18.7. This is your lower bound, this is your upper bound, so your error interval is going to be 18.5 and 18.7. Okay, next question. So you go up one value this time, down one value. Your halfway is 35.35. Halfway here is 35.45. So your error interval is in seconds this time, so I'll use S. So I get 35.35 and 35.45. It does not matter which letter you use in the middle of your interval. Okay, moving on, question 4. So this is to the nearest hundredth of a second, that's your hundredth of a second. So let's pop 60.74 in the middle. So I get 60.75, 60.73. So my halfway value here is 60.735 and 60.745. So my error interval, let's call it T for time, is 60.735 and 60.745. Okay, this one here then. So my value in the middle is 16.4, nearest 2 millimeters, up to 16.6, down to 16.2, halfway 16.3, 16.5, that's your lower bound, that's your upper bound. Let's pop them in. So I get 16.3 and 16.5. And the last one here then, it's been rounded to 2 decimal places. So pop 7.36 in the middle, 7.37, 7.35. Halfway then is 7.355, 7.365. That's your lower bound, that's your upper bound, and my error interval, the lower bound is included and the upper bound is not. Okay, hopefully you got all of those correct. What I want you to do now is complete the worksheet and then complete your exit pass.